Okay, today we're talking about polynomial intervals of increase and decrease. All right, question number 1. Now, I know on your papers you don't have all of that, but we're going to talk about all 6 of these characteristics. So as we work through each problem, you can just write these in somewhere. Okay, the first thing that we need to discuss, though, is that when we're doing intervals of increase and decrease, we're only concerned with the x values. Okay, so write that down. We are only concerned with the x values when we're looking at intervals of increase and decrease. So that means we're reading the graph from left to right. Yeah, because if we only care about x values, the x-axis is the horizontal one, so we're only looking from left to right. Now, when we write intervals of increase and decrease, we're going to write them in parentheses. Okay, now the reason you got colored pencils is because we are going to highlight the graph where it increases and where it decreases. So I'm going to highlight this word increase in this mint green color, and then I'm going to go over here and highlight where it is increasing. I got it, Jordan. I got it.
That color look clean.
Who is that?
Okay, so think of this like a roller coaster, okay? So here's the little cart that you're in. Okay, here you are screaming. Okay, now, say you're on a roller coaster and you're moving from left to right, okay? Here's the left side of the graph, here's the right side of the graph. So you kind of have to ignore that arrow because we're going from left to right. Are you going up a hill or down a hill? Up. So that would be considered increasing. Okay, but then once you get to the top of the hill, you obviously will go down a hill. Okay, so I'm going to pick a different color for that one. Let's go with this pink color. So decreasing, I'm going to use pink. You use whatever you've got. Yep, all the way down until it quits decreasing. And then you can see once again when you get to the bottom of that hill that you're going to go up another hill on the roller coaster. So there's another area that you are increasing. Okay, does that make sense? Okay, another thing that I like to do is I like to kind of highlight or darken the points where I change directions. Like when I hit that point, I'm no longer increasing, I'm decreasing. But when I hit this point, I stop decreasing and I begin increasing. Okay, any questions so far? Okay, so obviously we have 2 places where it's increasing. So over here I'm going to set up 2 intervals of increase. And remember I write them with parentheses. And since there's 2 of them, I'm going to write this symbol, U for union. Okay, now, when over here did you begin increasing? Okay, well, look, what does this arrow mean? So didn't this hill start a long time ago over here? So negative infinity, right? Because this arrow means that it goes forever like that. So, why is it negative infinity? It's going left, right? And we only care about x values, which is left, right, and it's going left, which is negative infinity. Now, as you go up this hill on the roller coaster, isn't this where you stop increasing? And what is that x value? Negative 1, 2, 3, right? Okay, look, I started increasing somewhere down here. I don't know because it goes forever. So negative infinity. But then I increase, I go way up this hill, and then right here is where I stop increasing. And that's at negative 3 on the x-axis. Okay, so now I start decreasing at that negative 3. And when do I quit decreasing? positive 4. Okay, now, right there at positive 4, don't I begin increasing again? And how long do I increase? Forever, so infinity. Okay, now, do you see how this negative 3 and 4 are the same numbers we had up here in the intervals of increase? And wouldn't that make sense? Because when you stop increasing, doesn't that mean you're starting to decrease? So that's why those numbers are in both. Okay, now let's talk about maximum and minimum. Who thinks they can go up there and place their finger on the highest point of that graph? Okay, Jacob, go. Yeah, you're going to write all this in. Okay, Jacob, go put your finger on where you think the highest part of the graph is. I don't know. No. Shh, just go. Okay. It just means there's 2 of them. Okay, did y'all see where Jacob pointed? He pointed right here. So, does that mean that this point is the highest point on this graph? So, look, what does this arrow mean? So, doesn't this go up forever? So, isn't that going to get higher than that? Will you ever be able to place your finger on the highest point? No, because it keeps going up forever, so the maximum does not exist. Now, what Jacob was pointing at is what we call a relative maximum, the highest point in a particular section of the graph. So if we just focus in on just what we can see on this graph, yeah, that's the highest point. But that's not the maximum because we would never find a true maximum. That's a relative maximum. And what are the coordinates of that point? Five, yeah. If you go up 1, 2, 3, 4, 5. Okay, so do you think you can ever place your finger on the lowest point of the graph? No, because since this arrow means that this part goes down forever, you obviously can't place your finger on the lowest point because it will continue going down forever. So that one does not exist, but is there a relative minimum? In that right here? And so its coordinates are right 4, down 5, so positive 4, negative 5. Okay, can we go to the next question now? Okay, so once again, the first thing I'm going to focus on is the intervals of increase. How many times is that graph increasing? 2. Over here you're going up a hill, and then over here you're going up. Okay, so when I write that over here in interval notation, when did this part start increasing? Right, the arrow means that actually it goes a lot farther down, and it will never stop. It will forever go down. So we don't know when it started. We just know that it goes left forever, so negative infinity. When did it stop increasing? At negative 2. Okay, but it also has another place where it increases, and when did it start? Positive 3. And how long did it increase? Forever, so positive infinity. Okay, does it decrease? Yes, right here. And so when did it begin decreasing? Right, negative 2, which makes sense because that's where it quit increasing up here. And then 3, because that's where it started increasing again. Okay, maximum. Can you place your finger on the highest point of that graph? No, because this arrow means that this continues to go up forever, up and right forever, so you can never place your finger on the highest point. Could you place your finger on the lowest point? No. if you're just looking at just what we can see on this coordinate plane, is there a relative maximum? Yes, right here at -2, 0. And what about a relative minimum? What would the coordinates of the relative minimum be? The lowest point of just what's on that graph. 3, -4. Okay, I'm going to give you a couple of minutes, and I want you to try the third one by yourself. Do all 6 things. Okay, how many times does this graph increase? Once, right here. How many times does it decrease? Twice. So I could go ahead and write over here 1 set of parentheses for there and 2 for here. Okay, when did it start increasing? -4. And then if you follow it up, when did it quit increasing? 5 is the y value. 0. Because remember, we're only concerned with the x value. So the x value at that point is 0. Okay, now if we go to the decreasing parts, when did it start decreasing? -infinity. Now some of you may be thinking, well, why is that negative? Because it's going up. But do we care about up and down? We only care about left to right, and this one's going left. So that's -infinity. Okay, so I'm going down the hill. When did it quit decreasing? Which would make complete sense because that's when we said it started increasing. And then over here, when did it begin decreasing? 0, which would make sense because that's when it finished increasing. And how long does it decrease? Forever. But it's positive because even though that's going down, that doesn't matter. It's going right, which is what's important to us because we're only concerned with the x values. All right, is there a maximum? Okay, look. Here, this is an up arrow, so we could never find a highest point because as it goes left, it continues going up. So the maximum does not exist. What about a minimum? Nope, does not exist. What about a relative max? What's the coordinates of it? 0, 5. Relative min? Right. No, really that point doesn't even have to be plotted there. Just go with where it changes directions. Okay, now your classwork is to do 4 and 5 by yourself.